Question number 1. The question is about structure and bonding. It is an A1 question from Ionic Compounds. 1.1. Figure number 1 shows part of the structure of calcium oxide, CaO. So this structure is actually the structure of calcium oxide. What type of the bonding is present in calcium oxide? Calcium is metal and oxygen is a non-metal. Calcium belongs to group number 2, Ca. It belongs to group number 2, whereas oxygen belongs to group number 6. Calcium is metal and oxygen is non-metal. Calcium loses 2 electrons and get +2 charge as shown here, and oxygen gains 2 electrons from calcium and gains -2 charge, which is given here. As the result of these opposite charges, a force of attraction develops between calcium and oxygen, between the positive charge and the negative charge ions, and that force of attraction creates a bond, and that bonding is called ionic bonding. The correct answer is ionic bonding. 1.2. 1.2 is also an AO1 question, and it is from the covalent bonding topic. 1.2 says, figure number 2 shows a particle of methane CH4. Here in methane, carbon is non-metal and hydrogen is also a non-metal, and it is a single molecule. If you look here, both are non-metals. A bond formed between the non-metals is not an ionic bond. It is not making a joint structure, so it is not a lattice structure here. If we look into the diagram, figure number 2, we can see that it is a single molecule. Therefore, it is not making a polymer, a long chain molecule. So it is living as a single molecule, so it is a molecular structure. So what type of the particle is present in figure number 2? It is a simple molecule of methane. Question number 1.3. It is an AO1 question. Figure number 3 shows the structure of carbon C60. This question is from graphene and fullerene. So this is a structure in which the particles are present here, which are highlighted. They are carbon atoms, and it is a hollow ball structure. If you look into the question, complete the sentence, choose the answer from the box. One option is diatomic. It is not diatomic structure. It doesn't consist of 2 atoms. It consists of only one kind of the atoms, that is carbon atoms. So carbon is a non-metal. So as the result of that, so it is not making any joint metallic structure. It consists of one kind of the particles, so there is no positive or negative charge ions are present in this structure. So it is not making any joint ionic structure. So it is just structure of fullerene here. The structure of carbon C60 is a fullerene. Figure number 4 shows the structure of graphite. Graphite is an allotropic form of carbon. If you look into the structure here, it consists of carbon atom. One carbon atom make bonds with another carbon atom, 1, 2, and 3. So there are 3 covalent bonds are present. Now we have to look into that. What type of the bond is labeled A in figure number 4? So they are looking into this kind of the bond here. If you look, there is only one line present, so it is not making any double bond. If you look here, it is consists of only the carbon atoms, so there is no positive and negative ions are present here, so the bond is not an ionic bonding. Carbon is a non-metal, so it is not making any metallic bond. This single line between carbon-carbon atoms is covalent bonding. One point five is again an AO1 question, and it is from structure of graphite. In graphite, each carbon atom forms bonds with the other carbon atom as shown in figure number 4. How many electrons does one carbon atom use to form one bond? Tick one box. Count the number of bonds formed by one carbon atom. If I go back to the figure number 4, we can count from here. If I'm going to use this carbon atom, it make one bond here, second bond here, third bond here. Each carbon atom is sharing one electron with the other one. So the one line means single covalent bond. Single means one carbon atom makes one bond with the other carbon atom. One carbon atom makes one bond with the other carbon atom. One carbon atom makes one bond with the other carbon atom. So each carbon atom shares one electron with other carbon atom. So how many electrons does one carbon atom use to form one covalent bond? So each carbon atom shares one electron with the other carbon atom. The correct answer is 1. An electric current is passed through the copper. So this is the copper wire. Figure number 5 shows the apparatus used here. This is the power supply. This is the filament bulb. It lights up when the current flows through the copper wire. Copper is a metal, and we know that metals are good conductor of electricity. Question number 1.6 is a one question. The student must have the knowledge about the metals and the properties of metals. And the property which is used in this question is about the conduction of the electricity through the metal wire, which is copper one. Complete the sentence. Choose the answer from the box. Different options are given here. Figure number 5 shows the copper conducts electricity as, the options are as a gas form, liquid form, solution form, or in solid form. If you go back here, we can see that between these two electrodes are given here in the black color, and the metal wire is present between them, which is copper, which is in solid form. It is not in gas form. It is not in liquid form. There is no solution of copper is present here. So it means that it is present in solid form. So figure number 5 shows the copper conducts electricity as a solid. Question number 7, 1.7, which is again an AO1 question. Complete the sentence. Choose the answer from the box, which is again from the topic metals as a conductors. Different options are given to complete the sentence. Copper conducts electricity because of movement of delocalized It means the free. Now we have to see that what the correct information is because it is a metal. So in metals, atoms are not free to move. The ions are not present there to move. In metals, molecules are not available. So it is a property of the metals that there are the free electrons are present which can move within the structure and conduct electricity. So delocalized electrons are present in the metals, which are responsible for the conduction of electricity. Question number 1.8, it is an AO1 question. Figure number 6 shows the apparatus used to investigate the effect of electricity on sodium chloride solution. So sodium chloride is an ionic compound. If we look here in this figure, the solution of ionic compound is given. This is a solution of ionic compound. Power supply is given, and if the current flows, the filament bulb lights up. The student must have good information about the properties of ionic compound. Again, we need to complete a sentence here. Choose answer from the box. Figure number 6 shows the sodium chloride conducts electricity. The properties of the ionic compound is the ionic compounds conduct electricity in two forms, in molten form or in the aqueous solution, mean dissolved in water. Because there are free ions in these two states to move. Now we have to see that it is a solution, so therefore it is not in a molten state. So it is a solution of sodium chloride, so it is not in gaseous form. So sodium chloride conducts electricity when it is in dissolved form. The extra information is the student must know the properties of the ionic compounds. Ionic compounds conduct electricity in two forms, in molten form or in aqueous solution, because there are free ions to move. Question number 1.9. This is again an AO1 question. Sodium chloride is made up of ions, sodium ion and chloride ion. And this topic is coming from the properties of ionic compounds. Figure number 7 shows the apparatus used to investigate the effect of electricity on solid sodium chloride and molten sodium chloride. So the student must have the information, or they have to remember the properties of the ionic compound, how the current will flow through an ionic compound. If you look into this diagram, the solid sodium chloride is present. The power supply is present. The key information is given here. The filament bulb doesn't light up. If we look here, this is the molten sodium chloride. So as compared to the solid sodium chloride, molten sodium chloride has free ions. And when the free ions are present, they are responsible for conduction of electricity. Therefore, the key information is given here. The filament bulb lights up because free ions are present to conduct the electricity. Table number 1 shows some information. Let's see the results. Observation. When it is in solid form, the light bulb doesn't light up. And what the results are you are deducing here, it means the current is not flowing. Therefore, the bulb doesn't light up. Whereas in molten sodium chloride, the filament bulb lights up. It means the current is flowing through this filament lamp. Draw one line from each statement to the correct answer. The statement is given here, the reason is given here. Sodium chloride's solid sodium chloride doesn't conduct electricity. In solid sodium chloride, if ions are not free, so current cannot flow through. So it means the ions are fixed. Molten sodium chloride conducts electricity. The three options are given here. The ions are mobile, the ions are neutral, the ions are vibrating. The ions are neutral, it is not possible. In molten sodium chloride, the ions are vibrating. If you look back into the properties of ionic compounds, in molten ionic compound, the ions are free to move, so they are not vibrating. So, in molten sodium chloride, the ions are mobile, means they are free to move.